everyone. What I would like to do today is talk a little bit more about direction angles and what you should be able to do by the end of today's work and video is understand how to represent a vector specifically with its direction angle. Or if you are given a direction angle, you can still write the vector. So what I'd like to do is go through these notes together, and we're going to start with the unit circle. So what we know about the unit circle is that the radius is 1. If you think about the radius as a vector, that would mean its magnitude is 1, or its length is 1. So let's suppose we have a vector v that has a direction angle of 45 degrees. So we're going to draw the vector. So I'm going to start on the positive x-axis, just like we did yesterday, and I'm also going to draw a vector that is 45 degrees away from the positive x-axis. We know that this vector has a magnitude of 1, but if I wanted to write this in component form, I really need to know the horizontal and the vertical component of this vector. Lucky for us, we all passed last semester, and we know that this coordinate at 45 degrees is rad 2 over 2, rad 2 over 2, which means our horizontal component and our vertical component are the same. So if I wanted to write this in component form, I would write rad 2 over 2, rad 2 over 2. Now just for fun, because I know you don't want to just take my word, we're going to check out that the magnitude is actually 1. So if I think about my magnitude formula, I'm going to use the distance formula, and I'm going to square the horizontal component and add it to the square of the vertical component. Well, the square root of, let's simplify this, the square root of 2 squared is 2. And in our denominator we have 2 squared, which is 4, plus, same thing, 2 over 4. And if I think about adding these together, 2/4 plus 2/4 is like thinking of 1/2 plus 1/2, which is 1. And our square root of 1 is 1. So yes, any vector we create using a coordinate on the unit circle, because the radius is 1, also shows that the magnitude is 1. Now yesterday, let me go on to the next page. Oh, I'm sorry, before we go to yesterday, let's suppose that our vector gets super long and it extends outside of the unit circle. And instead of having a magnitude of 1, it has a magnitude of 10. Well, if I'm thinking about my unit circle and my vector having a magnitude of 1, I would want this vector to be super long. I would want it to be 10 times bigger because I want it to have a magnitude of 10. I'm taking that magnitude of 1, and I want it to be 10 times the size. Well, that means my vector is also going to be 10 times the size. So if I knew my vector was rad 2 over 2, rad 2 over 2, I want this to be 10 times bigger. So what I would calculate is 10 times rad 2 over 2 and 10 times rad 2 over 2. What does that give me? Well, it gives me 10 rad 2 divided by 2, which I could simplify to be 5 rad 2, 5 rad 2. So when I think about being given a magnitude and a direction, there is a way I can find a vector. We're going to formalize this in just a second. Now yesterday in class I asked you, if I gave you a vector, could you graph it and tell me what the direction angle is? Would I be able to do that and prove that the vector we just came up with has a direction angle of 45 degrees? And I want you to think back to yesterday. We graphed these. So let's say this vector is here, and it has a horizontal component of 5 rad 2 and a vertical component of 5 rad 2. A lot of you said, oh, I can find that angle, theta, by using inverse tan. So if I took the inverse tan of my opposite side over my adjacent side. Because they're the same, I'm taking the inverse tan of 1, which would give me 45 degrees. So we just went backwards and forwards, or forwards and backwards, but let's formalize these ideas. So if I go to your next page, if you go to page 2, if you ever want to find a vector, and you are given a direction angle and a magnitude, you take the magnitude and you multiply it by the cosine of that angle. Or really, that's the x value. And then you take the magnitude and you multiply it by the sine of that angle, which is really just a y value. That will always give you a vector. Now, if you want to find the direction angle, what you can do is you can always use the inverse tan of the y value over the x value. Always. We can draw a triangle and we can find the inverse tan to help us find the direction angle. So you have some practice on the next page, and I think it would be helpful if I went through number 1 with you. So number 1, I believe, says the magnitude of a vector is 5, and the direction angle is 120 degrees. Can you write this vector in simplified component form? Well, I sure can, using a formula I came up with above. So I want to think this vector can be completed by finding the magnitude times the cosine of an angle and the magnitude times the sine of an angle. So my magnitude is 5. And then I want to find the cosine of 120 degrees. Then, same thing, my magnitude is 5 times the sine of 120 degrees. Now you can use your calculator for this, or we can think about our unit circle, and we can think at 120 degrees, that coordinate is negative 1/2 rad 3 over 2. I believe that should still be in your graphing calculator. You could also use your calculator to compute this just by typing this in. I'm okay with either way. I'm going to go ahead and use this form. So 5 times, well, the cosine of 120 is the x value, which is negative 1/2. And the sine value of 120 is rad 3 over 2. If I write this in simplified form, I get negative 5 over 2, 5 rad 3 over 2. And that's my final answer in component form. You have 6 more of these to practice, and I encourage you to try those on your own. The following problems are all finding the angle using the tangent values. Good luck!